All right, good morning, everybody. This is the first attempt actually it's the second attempt to record a practice lesson on some of the Physics 108 material, specifically in preparation on your midterm number 2. Okay, so I'm going to cover, as usual, some exercises from the end of the chapter, and then we're going to look over them or some of them during the review session very quickly, but you'll be able to look at these videos hopefully and see if you can reproduce these results on your own following these examples as well as the others in the study guide. Okay, so we're going to start from chapter 25, which is the last one that we covered, and the first problem that I already have here on the board is the problem number 7. Okay, so I'm going to read aloud the problem that says, calculate the index of refraction of a medium in which the speed of light is 2.012 times 10 to the 8 meter per second. And identify the most likely substance based on the table 25.1. We're going to do that. We're not going to do that part. But here is the term of the problem. What we wanted to find is the index of refraction of this material. So the way you want to imagine this, you have a substance and the speed of light changes when you go into the substance and slow down. So we know that the velocity in this substance is 2.012 10 to the 8 meter per second. And so we're going to just use the definition of index of refraction, which is the little letter n, which is the ratio between the speed of light and the velocity of light in the medium. Okay. Now for this problem, you can use either 3.0 10 to the 8 meter per second, which is the most simple version of it, or in this case I'm using a little bit more accurate version, which is 2.997 10 to the 8 meter per second. Doesn't really matter for your exams. Okay, so again, the index of refraction of a medium is the ratio between the speed of light and the speed of light in vacuum and the speed of light into the medium. So it's 2.997 10 to the 8 meter per second divided by the velocity we've been given, 2.012 10 to the 8 meter per second. Bring your units with you as usual, so you realize that the units cancel out and the index of refraction is 1.49. Okay? The second problem that I would like to attack is problem number 10, which is about a scuba diver in a swimming pool. And the scuba diver is looking at from the pool, from the water, out to the person on the edge of the pool. Okay, so here's the person on the edge. Here's the person is a scuba diver. And I hope you can read this. So the scuba diver is at 2 meters away from the person and is also 2 meters from the level of the water vertically. Okay, so what do we know? Well, what we want to find, so we have this angle theta 1, which is what we want, is the angle from the vertical, from the perpendicular to the water, with which the person outside the swimming pool sees the diver. And we know that the angle between the ray in the water and the perpendicular to the water, again, this is the perpendicular to the water, is theta 2 is equal to 25 degrees. So let's see, theta 2 is 25 degrees. The index of refraction of medium number 1, which I call air, in medium number 2 is water, is for air, the index of refraction is equal to 1. The index of refraction for water is 1.333. Again, in the exam, these numbers will be provided. I'm not expecting you to, well, air, you should know that air is 1, but in case of water or other substances, I will give it to you, okay? So what do we use at this point now that we have all this information? Well, this is a simple refraction mechanism, and so we use Snell's law. And Snell's law tells you that the index of refraction in the first medium times the angle, the sine of the angle theta 1 is equal to n2 the sine of theta 2. Okay? We are asked to find theta 2. Okay? So we have n1, we have n2, we also have, we have to find theta 1. We have theta 2, so we just solve it for sine theta 1, this equation. So sine of theta 1 is equal to n2, the sine of theta 2 divided by n1. Okay? And so what does it mean? This means that n2 is 1.33. The sine of theta 2 divided by, in this case, theta 2 is known and is 25 degrees. And then n1 is just 1. Okay? So how do we find theta 1? Well, we just have to invert that. So theta 1 is the sine to the minus 1 of 1.33 times the sine of 25 degrees. And that number is, and this is divided by 1, 34.3 degrees. Okay? Okay, so I'm going to stop here this video, and then we're going to move on after I clear the board.